let's start at the beginning. I want to review it very quickly. So we started talking about the types of material, and then we said we will focus on conductors and what happens to conductors when you place them in E fields. And we said there will be two kinds of conditions. One will be static and the other one will be dynamic. Static is when charges stop moving once they reach their destinations, whereas dynamic conditions are where they don't stop moving and there is no destination and they keep going. So this chapter 2 kind of focused on the static condition where, charges were stuck in place, whereas now in chapter 7, we're going to be discussing the dynamic condition. And then we talked about current and current density. We talked about J, which is the current per unit area. We also talked about the drift speed and how that is affected, and we developed a formula for the drift speed. And we also said that current density, we also developed a formula for current density in terms of its drift speed. Additionally, Griffiths does a development of a similar equation, but he does it in terms of thermal energy. I think it is worth you guys having a look at it. I won't do it here, but it's actually quite interesting and you should look at it at some point. Then we started talking about how do you get the current to flow, and we said you have to push it. That helped us develop something called force per unit charge. And from there, we developed conductivity and resistivity, and we developed their formulas, and we developed Ohm's law. Then we said that the Ohm's law can be written in these two forms. And Ohm's law only holds for materials that are isotropic. That means they have equal values as they go outwards. And those kinds of materials are called ohmic materials. And if you were to plot the graphs of delta V and I, the graphs for ohmic materials are a straight line. And the graph for non-ohmic materials are kind of like the ones that are shown towards the right side. Okay, that helps us develop, that helped us develop a concept of resistance versus resistivity. And I want to talk a little bit more about the actual difference between resistance and resistivity and develop the formula that is important. Suppose you have a conductor of length L and cross-sectional area A, and it is being held at a potential difference of delta V. So in this case, for a conductor, E inside is uniform, given by the formula delta V over L. That's the same equation, the ED equation that we've been talking about. Remember? Delta V equals integration E dot ds that we saw in chapter 2. And current density is J I over A. And current density is also uniform. So then may I write my Ohm's law as or what is V over I? V equals IR. So V over I is R. So then may I write this as using Ohm's law? Now, what will the units of resistivity be? Right? Area is meter squared, L is meters. So the units for resistivity are ohm meter. Whereas the unit of resistance are just ohms. Okay, so now I can rewrite this as what are the differences between resistivity and resistance? Okay, so number one, well, first of all, resistivity, the units are ohm meter. Resistance, the units are just ohms. Resistivity is the characteristic of the material under consideration. Whereas resistance is the characteristic of the particular object itself. In most cases, resistivity can be found in a table. People have done those calculations for you. They put it in the table. For every single material that you have, you can find the value of resistivity. Whereas resistance depends on the material, the shape, the size, the length, the cross-sectional area, etc. In general, resistivity is found by using this Ohm's law equation. Whereas resistance is rho L over A. Are we good? Okay, so do you know the difference now between resistivity and resistance? So the resistances that you pick up in the lab, they're like 470 kilo ohms or 70 kilo ohms or 1,000 or 1 mega ohm or whatever it is. That all depends on the shape and the size and all of those things. Whereas copper will have one resistivity versus brass will have one, gold will have one, silver will have something else, right? That's called the resistivity.